Let me tell you a story. Once upon a time, there were browsers and they were at war. And so they were fighting over features. And in the kingdom of Netscape, they decided we will need client-side languages. And their knight Brendan Knight came to the rescue, and in only 10 days, they had JavaScript. But all was not good, because now the local brewery could access data from the king's treasury. So, to avoid that, they also developed the same origin policy to keep him out. But this doesn't really hold for all content types, including scripts and JSONP. And they can be included cross-domain, and that is why we have cross-site script inclusion, and that was the tale of a fameless but widespread vulnerability. My name is Veit Hailperin. I'm not Ashar, and this talk is definitely not about cross-site scripting, even though the name does sound close. It has nothing to do with it. So toss it out, and if you ever want to give feedback on the feedback list later on, you probably have to put it into Ashar, but just know that you're not giving Ashar the feedback, but you're giving me the feedback. So be nice. All right. You can find me on Twitter. And yeah, so name was Veit, not Ashar. And I work for a company called Skip here in Switzerland. Just about 3 minutes that way. And it's a security company. We do offensive security. We do defensive security. I'm in the offensive security department. Lots of auditing, pen tests, web apps, networks, all that stuff. We do research, and it does overlap, as this amazing graph shows you. And oh, that's what you were not wondering about that. All right, so in case I was too quick just beforehand, cross-site script inclusion, how does this work? So for that, I'd like to quickly go into a live demo. Let's see if this fails. So we need to quickly look at something that is very, very essential, and that's the same origin policy. So I've mentioned the same origin policy quickly, and the same origin policy, basically, what it is, it's supposed to keep you out, supposed to keep you from accessing data that's on different websites. And this is a bit abstract, maybe for some of you, this might be the most normal thing ever, but I decided that we're gonna quickly look at what that means. So what we're gonna do is we're gonna have an A-frame, and we're gonna call it area, and the source is gonna be, it's gotta be HTTPS, otherwise it's gonna have a mixed content arrow. Can I do this a little bit smaller and you'll still see it? So, area. So let's take area41.io. Let's access their data. Agenda, whatever. Yeah, so we include that. And then now we want to access their data. So we go window.frames, and we access that frame. And we go, give us that document. And we run. And it loads the image, so something. It frames the page, but the moment I want to access it, you can see down here, and I'm not sure if you can see it. Uncaught security error blocked a frame with origin from accessing a frame with origin area41.io. Protocols, domains, and ports must match. So basically, what that is, that's the same origin policy. The same protocol, the same domain, and the same port. That goes for all browsers except Internet Explorer. So yeah, so usually when we talk about same origin policy, we assume the one of modern browsers. All right. So let's clear this out and see what happens when we include a script. Actually, I'm gonna. So we have a text JavaScript. And we have a source, and I'm going to copy this URL because this is too much to type. All right, run. System not defined. Let's clear this just so we don't get wrong errors. All right, that's an error inside the Angular 2.js. So it's already executing it, it's loading it in. There's no, this is directly script, so we're not executing anything down here. If this would be illegal, it would throw an error down here about the origin and not about an JavaScript error. So basically what we're seeing here now is that as soon as data is in form of scripts, you can access it. Like this is the usual way of including model view controller framework in JavaScript, and then afterwards you can work with it. So basically, this is, we could say, behavior as intended. Yeah, it's nothing out of the extraordinary. But what happens, and this is the key point about this vulnerability type, is that what happens if there is sensitive data in JavaScript files, and then it is the same way as with functionality, you can still access it, and that's when you have data leakage. And now you also see why the name, where the name comes from, to include scripts cross-site. And that's all it is. That's really all it is. But let's look at one more thing. So what about ambient authority? So ambient authority is another word or a term we toss around very much in our field of pen testing or security. But ambient authority is authority information that is globally stored and accessible, such as cookies, which are like in a cookie jar available. And so I quickly need you to raise hands to who is a pen tester in this room? Or, all right, who's a developer? All right, what's the rest doing? There's just these two options in my world. No, so basically it works the same as with cross-site request forgery. But in cross-site request forgery, for those that don't know what it is, basically you send a post request to a website from a malicious site, and that if the user is logged into the other site, you can execute stuff in the context of the user because the user is authenticated and that cookie information is sent along despite it being originating from another source. And that's the same with cross-site script inclusion. So if I include a script from another website and the users log into that website, all the ambient authority information, such as cookies, is sent along. So if the script contains stuff that is only for that session or only for that user, we'll get that data. And so now you start to see why this is actually something we have to take serious, because that is user context relevant data. So I'd like to look at another example, and this is an example from a website. It's a top Alexa 150 page, so it's has a quite good base of users. I'll just see what we found. So I have to explain a little more. Some of you might know JSON fairly well, maybe even personally, but so we have basically JSON is nothing else than object notation for JavaScript. Yeah, that's what it stands for. And it's a key value pair. So as you can see, for example, there it goes status, that's a key, and the value is 200. Comma, there's the next key, and then there's the next value. And the next value is a little bit more complicated when it's a new JSON object. Now in this case, if you return data as JSON, you can't access it cross-domain, because the curly braces that we have here in the beginning, after the foo open parentheses, there's curly braces here, and they're not possibly valid JavaScript in the context of that. So you can't execute it. If I would include that cross-domain, it would throw an error. But this is JSON-P, which is JSON with padding, and you provide a callback function to that JSON, and what it does is you see here that callback is a parameter, And that parameter is basically the function name, and that is just with the open parentheses and then close parentheses. So it just gets wrapped around it. So this gives us, of course, access to the data, and it is valid script. So basically, what we are going to do now to exploit this, we're going to go from bottom to top, very counterintuitive, but we include the script as we did before with the source, and then we provide our own callback, which we're going to call leak, and it's a type text JavaScript, voila. And then up here, we define the callback that we're passing on to them, and it's going to take an argument, which is afterwards they're going to be the JSON, of course, and we're doing nothing else than JSON stringify of the leaked data in there. So if we, I'm not sure if you saw what was in that data. So there's email address, there's first name, there's last name, there's the phone number, there's a username, there's the gender, there's the date of birth, there's the location with exact geolocation data. So now, as you've seen, the exploit is not particularly difficult. If you manage to get anybody on that website who's logged in, and it's a website that doesn't make any sense if you're not logged in, to be honest, I blurred it out because they haven't fixed it, which might be partially because they don't know about it. I never reported it, but that's a different it's a different story. And they really have other issues than this, which is not good for them. But yeah, so as soon as somebody goes now to a website where this is written, they'll see this. So basically, I've got access now on my malicious website to the content that the other site sent back. This is bad. This is really bad. This is way too much personal information, way too sensitive data to just get like exploited with basically one line. Yeah. So yeah, I did say Fameless. Thanks for asking. There's one book that I like very much, and it's The Tangled Web by Michael Zalewski. It's for developers. I highly recommend it if you haven't read it. If you're a pen tester and you haven't read it, I highly recommend it too. There is a German translation by Mario Heiderich, and XSSI, this type of vulnerability, it's mentioned in a footnote. This is how much fame it gets in like a book about security. This is not a critique about the book. It's more like it doesn't seem to appear important. And if you go to the OWASP website and you search for cross-site script inclusion, you'll find nothing. And if you search with the site.owasp.org on Google, you'll find 2 PDFs where cross-site script inclusion is mentioned, or about cross-site script inclusion. And basically, we have to think about this in a way that we say, all right, people come into our industry all the time, and what do they look at when they look for web vulnerabilities? Well, they look at the OWASP standard, and if it's not in the top 10, it's already got bad chances of being found, at least for beginners. And if it's not mentioned anywhere on that site, chances that anybody really cares about this is really, really low. So yeah, it is Fameless. But I also said it was widespread, and this is a quote from a paper, The Unexpected Dangers of Dynamic JavaScript. We observed that a third of the surveyed sites utilize dynamic JavaScript. More than 80% of the sites are susceptible to attacks via remote script inclusion. That is quite a lot. And recently somebody told me, I tried to search for it and I didn't find it on the first page, so I guess I stopped again. It's like, you should go through at least 3 pages, which is statistically like really, really low chance, but still. And to be honest, this is like a number that correlates with my daily pen tests that I do. And one more thing about this. This is just about dynamic JavaScript. But I'm talking about cross-site script inclusion, and that's just one part. And I think for vulnerabilities to get more traction, it's good if they're categorized and they're like, you can see the different scopes, like in XSS, you've got reflected and stored and DOM-based and universal and mutation-based, and you've got all the whole funky stories. And in cross-site script inclusion, it's a little bit like, it's a cross-site script inclusion vulnerability. We don't really know what it is exactly. So I hoped to fix this by categorizing them myself. So if you disagree with the categories, feel free to let me know if you have a better idea or whatever, but I think this sums it up pretty well. First category, static JavaScript or JSONP. With JSONP, of course, if there's other parameters, you have to know the values of them, otherwise it won't work. So if there's a cross-site request forgery token in there, unfortunately, it won't work. But otherwise, static JavaScript, you've seen it in the example, you just include it, and there it goes. And then there's static JavaScript requiring authentication, which I consider category number 2. And that is when you request something and you need the ambient authority to get that data. You need the user to be logged in. It's really funny. I don't see much in the back, but I see like blinking lights. It's nice. I know somebody's there. All right. Yeah. So as long as you send the cookies along, then you'll get access to different static scripts. And then category 3 is dynamic JavaScript. And dynamic JavaScript, basically, it can fall into the unauthenticated or into the authenticated category. Doesn't really matter. The point about dynamic JavaScript is it's generated on some basis. It could be because of a user logging in, so it could be dynamic on that, but it could be also dynamic because it's advertising or because there's a timestamp in it, which has to be renewed. So there's many reasons for dynamic JavaScript to be, but the interesting one for us is, and that's why I didn't distinguish between authenticated and unauthenticated one. The dynamic JavaScript really starts to get interesting when a user is in an authenticated context. So then when you request stuff, it will be dynamic on the user context, and then we'll have user data, user relevant data. And then there is a category number 4, which might sound a little odd because it's the non-script one. So cross-site non-script inclusion. Basically, the idea here is that we include data in the script tag in the source, as we saw in the JSFiddle example before, but it's not a script file that we're including. We're just saying include it as a script. And then JavaScript is a fairly loosely defined language, so we can trick sometimes the browser into thinking like, oh, this is JavaScript. All right, I think I see this. This is the identifier, and then there's a oh no, this didn't work. Well, I'll throw an error, but you'll still get access to the data. So this happened with all sorts of data, amongst others CSV data. That was a lot of fun. And there's a good paper about it by Takeshi Terada, which I highly recommend you read. Lots of the stuff he reported like years ago, and just some of them got fixed like end last year, beginning this year. So there's also chances you'll find more of that. But these issues, number 4, they're really browser issues, and the other one are application issues. So we'll not look too much into the category number 4, but mainly about the first 3. Let's find some cross-site script inclusion. So finding category number 1. You'll not get around it. You'll have to read the code, which might be unfortunate for you, especially if you don't like JavaScript. But there's, of course, some things that you can do to help this a little bit. So you can grab for public keys or private keys. You can grab for social security numbers. You can grab for credit card numbers. There's like regexes you can use for that. And if you're using Burp Suite, by the way, Burp's not beef, you'll have a support by Burp to do that. So it will already tell you if there's sensitive data inside a file. So this is nice if you have Burp. If you don't have Burp, this is a little bit more work. Finding category number 2 and 3 is a little bit like a mixed thing, so I decided to put it into this shape. To give you context for this, where we're starting, we are in the situation of browsing a website in an authenticated context. So it's important that we're in an authentic context. And authenticated context. And now that we've been like getting lots of the JavaScript files with the cookies sent along, what we'll do is we'll re-request the JavaScript file that we want to test, and we remove the ambient authority information. And if it's still a script, if it's not a script anymore, we know that if it's authenticated, we'll get a script, and if we're not, we don't. So there's a static JavaScript file that is only available while we're authenticated. If it is a script, we'll have to check if the answer differs from the original. And if it doesn't differ, it's just a JavaScript file, static, doesn't really matter. Script's not dynamic, script's not probably sensitive, unless category number 1. If it does differ, what we'll do is, we could just say, all right, so we've got a different one now in authenticated and in unauthenticated. So what we know already is there's something based on authentication. But what we'll now want to exclude is, we want to exclude the generically dynamic stuff. The stuff we've been talking about, the timestamps, the advertising. So we'll re-request it again. And if the answer doesn't differ again, so from the 2 unauthenticated ones, if they're the same, we'll know, yes, we've got dynamic JavaScript based on authentication. And if it differs again, it's just generically dynamic. So then you have nothing found. But this is basically how you go about it. It's not that tricky, really. It's just a little bit of an effort. And then category number 4, non-script. I want to show you this example because I think it's very funny. So what we see here is a JSON block. And it's not a JSON that starts with curly braces, but with brackets, square brackets. But that happens all the time, that you'll get JSON in that format. And you'll see the key value pair, friend, Luke, email. And then there is some UTF-7 encoded data. And that is obviously user provided, because when you sign up, you give your email. So this is your own data as a hacker. That's what you provided. And if we translate that, we'll see that this actually is quote, quote, curly braces, square brackets, semicolon. And it's like, oh, and then we just go with JavaScript alert, may the force be with you, and we'll keep going about our job. All right, so basically this is UTF-7 and translates to this. And if you include the script now on a malicious website, and you give the source, and it's JSON, it's not JavaScript, it's not JSON-P. This is really just JSON you're including as a script. And then you say type text JavaScript, and the char set you say UTF-7. The browser goes like, oh, I guess I should interpret this. It interprets it like this, and you're turning JSON into JavaScript, like executable. And that, of course, I mean, as you see the link down here, it's a hack by Gareth Hayes, great researcher. He did this in 2011. So, of course, all modern browsers have fixed this, and of course, all non-modern browsers haven't fixed this. So this still works in Internet Explorer. So, and just because why not? This, I mean, 2011 was not the year of Edge, but it would just not be fun if it wouldn't be an Edge. So it's also an Edge. All right, so this still works, yeah, and this is also why JSON, and this is for the developers here, JSON should never really use the square brackets in the beginning, because this is valid JavaScript, or can be valid JavaScript, while the curly braces can't. And even if your library allows it, it is really smart to go for the curly braces because there's browser issues you can't control, um, even if you report it to the browser vendors, apparently. Yeah. Um, yeah, there was other fun stuff. There was the CSV, as I've told you, but there was also one that we'll talk about later. Exploiting cross-site script inclusion. So I'm not particularly like really fancy about those JavaScript things. They don't look particularly pretty, but for those that know JavaScript, this will be really easy. For those that don't know JavaScript, I'll take it slow. All right. So what we have here is we have a global variable. You'll see a private key. By the way, this is an example from real life. This is not a made-up example. This is something I've seen. Um, yes, private key in a static, unauthenticated file in the global variable. Please don't do it, developers. And if you want to access, for example, the keys, you just get the data keys because it's global. You can take the first one because it's an array. It's a JSON format, so you have to stringify it before you pop the alert. And of course, you include it, the file, cross domain. That's the case of the global variable. Then function overriding is a little bit different, but basically you create a function, and if this was the response, you'll be like, all right, and then I'll have a sub-function and a sub-sub, and then at the last one, I'll actually take the data that's in there and leak it, and you call the website, you include the website, and you have access to the data. Now, somebody might notice that this looks very much like a JSON-P callback, so you don't need to override the function. You can just provide your own callback, as we did in the example. But in case it's not a callback, you can just override the functions. That's the beauty of the dynamicness of JavaScript. You can just at runtime just be like, all right, let's change that. And one of the big issues about this was that people were overriding the array constructor back in the days. And so if you return JSON in square brackets and the array constructor is overridden, you can just do anything with it. That used to be the case. That is not possible anymore. But function overriding itself is totally possible still. But it's not always as easy. Sometimes the data is inside a function, for example, a self-executing function. That's the parentheses in front. And if there's a self-executing function and there's inside that function, you won't be access it through there's a scope limitation. But usually data inside of functions is also manipulated. So in this case, the array with the secrets is passed to the function slice, and all we have to do is we have to tamper with the prototype. So we say, all right, array prototype.slice, which is where the function is defined. And again, we can do this at runtime. We'll be like, you are now a different function, even though I included that script from somewhere else. And now, of course, I can access it. And we are already getting to preventing cross-site script inclusion. Yeah, that's just a list of stuff, basically, you have to think about. So the easiest thing is to just never, ever put sensitive data into JSON-P callbacks or script files. If you don't do that, this vulnerability is just not relevant for your application anymore. The correct content type and the X-content type options no sniff. So the content type is basically, if that is not set or not set properly, it's easier for a browser to confuse comma-separated value with the script than if it comes back and says, I am a CSV file. And then the browser goes like, oh, you're trying to include that as a script. Oh no, wait, that's not possible because this is CSV. So setting the correct content type will help the browser to distinguish if this is valid or non-valid. And the X-content type options no sniff is to prevent any stupid char set sniffing on the side of the browser. that we want to avoid. Then, of course, the cross-site request forgery token uh, helps against the authentication-based XSSI. It doesn't help against the static, non-authenticated ones. Um, if you do that, it makes sense to send the CSRF token as a header, because those are all GET requests, and you don't want to have one that leaks easily through the URL. Um, all script inclusions, so if you have script source something, that is sent as a GET request. There is never POST requests, so you don't have to think about providing the CSRF token in the body of the post. And then the same site cookie attribute, this is an interesting one. This is currently just a draft. It's an RFC written by Mike West and Mark Goodwin. Mark Goodwin is from Mozilla and Mike West is at Google. And this was just released in April, so it's not that long ago. It's a draft, means it's not a standard yet. They're trying to make it a standard, and the same site cookie attribute, if you set it onto a cookie and you say same site strict, it's basically like it's in the same area where the HTTP only and the secure flags are located, then the cookie won't be sent from a different origin. So it will make sure that in the cookie jar, if you're trying to send stuff cross origin, it'll be like, this cookie just comes along if the request was sent from the same origin, which is really just patching the problem. But it is a good start, I guess. And for testers, spread the word, report them, put them in your reports if you find something. And in that context, we have to quickly talk about what do you get from script inclusion. So we have been talking about sensitive data all the time, like in static files, like public keys or private keys, or public keys are not that sensitive, but the whole user data, etc., etc. But in dynamic JavaScript and authentication-based cross-site script inclusion, one you'll always have if you get nothing from the script is a login oracle. So in the worst case, you'll know if the user's logged in or not. That always exists. And that might not be the big hit with your customers when you report it, but it might be worth just putting it in to be like, just letting you know, this is what happens, and this is possible, and if you will ever think about putting something sensitive in there, this will get way worse. Let's talk about a list of links and references. This is something I always like to present, because most of the work has been done by others and not by me. So the first link is Jeremiah Grossman's article on advanced web attacks, where he uses cross-site script inclusion to access the address book of Google users. That was in 2006, and it's been probably the first time the term cross-site script inclusion has been used. Then the next one is JSON is not as safe as people think it is. That's an article by, I don't know anymore exactly, but what this article talks about is the array, overriding the array constructor. And that's the one I've been telling you about. That doesn't exist anymore, that doesn't work anymore, but it's interesting anyway to know what they did and how they did it. And the next article by JSON hijacking, that's the one that I showed you that still works in Internet Explorer and newly also works in Edge. And that's by Gareth Hayes. Then the next issue is from the current frac. That's an article by Jörnchen from Phenolite, where he writes about Ruby. And it's Rails 3 that he writes about, really, and attacks about Rails 3. And those attacks are all sorts of attacks, but one of them is actually a cross-site script inclusion, and that is because in back then you could provide the format of the data that you wanted to return. So you could pass a parameter $format equals JSON, and you got it back as JSON, or you could say format equals XML, and you will get it back as an XML, and you could sometimes also say format equals JS, and you get it back as JavaScript. And since that is a parameter that is passed in the GET request, this is very easy. We can just, in the script inclusion, just be like, all right, we'll want this as JavaScript, and now we can access it. So that's that article. The next one is the one by Takeshi Terada that I've been mentioning. That's the identifier-based cross-site script inclusion, where with the CSV leaking, for example, but there is more stuff in there. That's a really fun read. The next paper is the one that inspired most of this getting into it. That's the one paper by Sebastian Likis, and this is the one about dynamic JavaScript, the unexpected dangers of dynamic JavaScript, the one I've been quoting before. And on the next one, you'll find different ways of leaking stuff. That's also by Sebastian. The post afterwards is a cross-site script inclusion vulnerability in Zendesk that existed, and Twitter was using Zendesk. So it was twitter.zendesk.com, and somehow, for some reason, if a user was logged in, they would send user-relevant data to Zendesk, and that was just standing there in a file that was called user.js. And so everybody who's logged into Twitter and visited a malicious website where the cross-site script inclusion vulnerability was exploited, they would just like get all the data. Very nice and fun attack. And last but not least, skip.ch, that's the labs article, the blog article about cross-site script inclusion vulnerabilities that I wrote. That's basically what I've been telling you about, more or less, with some extras and some less stuff that exists. And then this wouldn't be complete if I wouldn't be sharing the love. And of course, I hate doing stuff manually that I can automate. So I wrote a burp extension, which is in your burp store available. You can already install it. And what it does, it helps you find the cross-site script inclusion vulnerabilities that are authentication based. So number 2 and 3 mainly. And it doesn't really care too much about dynamic JavaScript that is boring. So they'll be reported as informations. And the other ones are mediums. And it works exactly as I described beforehand. So it fires 2 more requests. And you have to know this because if your passive scanner settings are too loose, it might just keep firing requests. And it's not that much. It's just 2 per JavaScript file maximum. But just know it's a passive scanner module, and we'll do that anyway. And it has to be that way, unfortunately, for the current moment, because active scanner modules are not really made for this purpose. I've talked with the guys from Portswigger, and they said, like, currently this is just the best way to do it. And so I leave it at that. And if they change the API, I might change the module type. For right now, it's that. It does filter for JSON-P and scripts, and it does also filter for JSON, because we can sometimes get out, as you've seen. So don't be surprised if you'll see JSON answers and you'll be like, why is this a script? It's not, but just check if you can exploit it in Internet Explorer or Edge. And for right now, the only ambient authority information that I've included in it are cookies. But I hope there is more to come, and I hope I'm using it at our place, and I think the noise is totally acceptable. If you don't think so, feel free to let me know. Put a request, a pull request, or make an issue or on GitHub, and I'll look into it. I'm very happy about feedback. I know this is not the most beautiful code. I'm not a developer. And with that, I'd like to thank you very much all for listening, and if there's any questions, shoot. All right. Is that about the amount of questions? Can we wrap this up? Everybody get some coffee, wake up. Yeah, I guess that. Thank you very much.